All right, so here we are in lesson 8.7, which is basic probability. Now, before we get started into examples with probability, we do need to understand some of the vocabulary that goes along with probability in experiments. So first we have outcomes. Outcomes are the possible results of an experiment. And if we put all of those outcomes together, they make what we call the sample space. So let's think about rolling a dice, for example. We just have a standard dice that has 6 sides. So if I were to list out the sample space for a dice, I'm going to roll the dice one time. I could roll a 1, or I could roll a 2, a 3, a 4, a 5, or a 6. So there's my sample space for rolling a dice. Now let's say I want to look at the probability of a specific event. An event is a sub-collection of that sample space. So maybe it's what you're trying to get to happen. So let's say my event is I want to figure out for the event of rolling a 5. Okay, so my event is just going to be that one number of a 5. Now, what's the probability of rolling a 5? Well, the probability is the number of successes divided by the number of failures. Sorry, the number of successes divided by the total. The total is the number of successes and failures together. So this denominator here is the total. So the probability of a success is a success divided by the total. The probability of a failure here is the number of failures divided by the total. So for this example, what's the probability of rolling a 5 on the dice? Well, I have one way that I can roll a 5, so that is one success out of 6 possible events in my sample space, or 6 possible outcomes, excuse me. All right, now the number of, or the odds is going to be the ratio of the number of successes to the number of failures now. So if this is my probability, then 1 represents the number of successes. That's the number of successes, and 6 represents the number of the total. I keep saying failures, is the number of the total. So that means here that the number of failures would be the successes subtracted from the total. So 6 minus 1. So there'll be 5 failures, which means that the odds of rolling a 5 on the dice would be 1 success to 5 failures. All right, then we have what we call mutually exclusive events, independent events, and the complement of an event. So mutually exclusive events are 2 events that are from the same sample space that have no outcomes in common. So this is important here. They have no outcomes in common. Okay. So let's take a look at 2 different situations here. So the probability of the union of 2 events. So we're looking at 2 events happening. So if we have 2 events in the same sample space, then we can do the probability of the union of those 2 events, which means the word or. So this is like the probability of this union here. That symbol for union means or. So the probability of A or B happening, you would take the sum of the 2, probability of A plus probability of B, and then you would subtract the intersection of A and B. This symbol right here, the upside down U, means intersection. And so that's the probability of A and B happening. And so I like to call that the overlap. All right, and so that happens with, let's say, a deck of cards. If we're saying, what's the probability of choosing a red card or a 5? Well, there is a red 5. There's actually 2 red 5s. And so we wouldn't want to count choosing a red 5 twice. And so we'd want to subtract that from the total. Now, if those 2 events, A and B, are mutually exclusive, right? So if they are mutually exclusive, meaning that they don't have any outcomes in common, then you don't have to subtract anything at the end, and you just add the 2 probabilities together. Independent events are 2 events such that the occurrence of one has no effect on the occurrence of the other. So when you're rolling dice, dice are independent events. So if you have 1 dice and a second dice, what happens on 1 dice does not affect the probability of what's going to happen on the second dice. Those probabilities are going to stay completely independent of each other. So to calculate probability for independent events, so the probability of A and B happening, we're simply going to multiply each of the independent probabilities together. Now the complement of an event, is simply 1 minus the probability of the event happening. So the probability of event happening and an event not happening is always going to equal 1. So the probability of an event plus the probability of not the event is always going to equal 1. Okay? And so the complement is going to just be 1 minus the probability of the event. So this I can also write as probability of the event, probability of the complement of the event. Okay. All right, let's get into some, one more thing, deck of cards. If you're not familiar with cards, here's just some information about a deck of cards. There's 52 total cards in a deck. We have 4 different suits. Red are hearts and diamonds, black are spades and clubs, 13 cards in each suit. So there's 13 hearts, 13 diamonds, 13 spades, and 13 clubs. The denominations, we have ace. Ace kind of represents a 1, 2, 3, 4, 5, all the way up to 10. And then we have jack, queen, king. There's 4 of each kind of card. So there's 4 aces, 4 jacks, 4 kings, 4 sevens, and so on. Face cards are jacks, queens, and kings. So there's 12 total face cards that exist. Okay, so you can keep that for reference if you're not familiar with decks of cards. All right, so let's take a look at some examples now. So here we have 3 coins that are tossed. We want to find the sample space of the event. So when you're finding the sample space, I recommend using some strategy and organization of the way you're calculating the sample or writing out the sample space. So we're just going to write out, we're tossing 3 coins. So we could either get heads or tails on each coin. So I'm first going to write out, well, what if my first toss was a head? So I could get a head. And if I also put my second toss as a head, so my first toss and second toss are heads, first and second. Keeping that consistent, I'm writing out what would be the options for the third. I could either get a head or a tail. Okay, so I've done the head to start. Next, I'm going to try, what if my first toss was a head and my second toss was a tail? So I kept that consistent. I had a head and a tail, a head and a tail. Then my third toss could be a head or it could be a tail. And I wrote that wrong. I wrote the same thing twice. Let me fix that. So it could be, whoops, a head, the first one, or it could be HTT. Okay. And then, okay, my next, I'm going to do that. What if my first coin was a tail? So I would have tail and head. So I kept my first 2 consistent here. So tail and then head, tail and then head. And I would either have a tail and a head as an option for the third. And then if I had 2 tails to start, what were my options from there? And that gives me all 8 of my options, which I can write out as a sample space like so. And I will let me fix that one that I mixed up. And so this one, should I put HTH on there twice? So that one should be HTT. All right, very good. So there we have our entire sample space, and that's how we write out a sample space. Now, state the odds of an event given the probability of the event is 7 over 15, right? Well, again, our probability we know is success divided by failure. So we have successes divided by failures. So that means we have 7 successes and we have 15. Sorry, I keep saying success divided by failure. Success divided by total. So we have 7 successes and 15 total, which means then we can figure out that we have 8 failures. So we do successes minus total minus successes to get the number of failures. So that makes our odds as 7 over 8. All right, go ahead and try number 3 on your own. You can pause the video right now. All right, so let's check your answer. So if the odds of the event is 10 over 1, we want to find the probability. Did you get the probability to be 10 over 11? All right, let's continue on with number 4. So here we have a bank contains 3 pennies, 8 nickels, 4 dimes, and 10 quarters. So first I'm looking at this. I have pennies, nickels, 4 dimes, and 10 quarters. I'm choosing 2 coins, okay? 2 coins. And we're selecting them at random, okay? So we're going to reach in and we're just going to grab out 2 coins. We want to find each probability. So the first thing that we would want to know is we want to know how many total coins are there and does the order matter? No, the order does not matter because we're reaching in and we're grabbing 2 at a time. So we have a total of 25 coins if I add up 3 plus 8 plus 4 plus 10. So 25 total coins, and the order doesn't matter. So I'm going to use combinations here. So if I want both of them to be quarters, I think about, okay, well, how many total quarters do I have? Well, I can see that I have 10 quarters, right? I have 10 quarters right here. So out of those 10 quarters, I need to choose 2. So that's going to be the number of successes. So my numerator is going to be 10C2. Now, how many total coins am I choosing from? 25. So from the 25, the number of options to choose 2 coins out of 25 would be 25C2. So I'm going to start with 10C2, and this is choosing 2 quarters from 10 quarters. And then I'm choosing 2 coins from 25 total coins for my sample space. And I just calculate that. You can use your calculator to calculate that if you would like. And here we end up with 3/20. All right, for letter B, I want 1 nickel and 1 dime. So we have the word and in here. So this word and in here means that we are going to be multiplying, okay? And so we want probability of 1 nickel. So we look at how many nickels do we have? Well, here I know I have 8 nickels, okay? So I have 8 nickels and I need to choose 1 nickel. And then how many dimes do I have? Well, I have 4 dimes. So 4 dimes. So out of 4 dimes, I'm going to choose 1 dime. Okay. And then my denominator, I'm still choosing 2 coins. So 8C1 for 8 nickels, and I'm choosing 1. 4C1 for 4 dimes, and I'm choosing 1. Anytime you're doing choosing 1, it's always just going to give you that number when you simplify. So you could also write this if you want to, or you could put it as just 8 times 4 over 25. Oops, not like that. Small 25C2. You can also write it like that if you'd like. And we just go ahead and we calculate that, and we end up with 8/75. All right. Let's go down to number 5. So a bag contains 5 red, 3 green, and 8 blue marbles. All right, so 5 red, 3 green, and 8 blue. 5 red, 3 green, and 8 blue. We're choosing 3, but now notice what it says. We're choosing 3 in sequence. Also, it says without replacement. So we're going to take one out, one at a time. We're not going to put it back. Okay. So what is the probability of selecting a red, a green, and a blue in that order? So does the order matter? Yes, in that order. All right. Now you can use a permutation here, but then the permutation is always going to be choosing 1. So it's always just going to be simplifying to that number. So I just like to write it without a permutation and just write it as is. So I am looking for here, what is the probability of a red, then I have a green, and then I have a blue. So I'm going to write it like that for my probability. Okay, so let me look at, well, I'm just choosing 1 coin. So I'm going to reach into the bag, I'm going to choose 1, marble. Reaching in, grabbing 1 marble. So how many red marbles are in the bag to start with? I have 5. So I have 5 ways to get a success. Out of how many total marbles do I have? I have 16 total marbles. Okay, so 5 out of 16 times. Now I've taken that 1 out. So how many total marbles are left in the bag? I only have 15 total left in the bag for my next choice. Well, now I've taken out 1 red. So now I'm going to pick out a green. Well, how many green are in the bag? I know that there's 3 still green in the bag because I picked out a red already. Okay. Times. Now I'm going to reach in. Again, I didn't put that 1 back, so I only have 14 total marbles in the bag. And how many blue are in there? There's 8. And you can go ahead and do some simplifying and reducing. So I could reduce the 8 and the 16 and a 1 and a 2, the 3/15ths and 1 over 5, and so on, the 5 and the 5. And then I end up with my answer of 1 over 28. All right, number 6. The letters of the alphabet are placed in a bag. All right, so A through Z are placed in a bag. What is the probability of selecting a vowel? All right, let's talk about this, a vowel. Vowels that we have are A, E, I, O, and U. Okay, we're not going to do any of these secondary vowels. Or one of the letters in the word quiz. Okay, now this one, it's an or problem. So what we need to think about is we need to think about, are these events of a vowel and the letters in the word quiz, are they mutually exclusive? So we're looking at, are there any outcomes that happen that are a vowel and are in the word quiz? And the answer is yes. So these are not mutually exclusive because look at, I have an I that's in both. I also have a U that's in both. So they're going to have overlap. So when I make my calculation here, the probability of a vowel or a letter of the word quiz is going to be the probability of a vowel minus the probability of one of the letters of the word quiz, plus the probability of one of the letters of the word quiz, minus the probability of the overlap. Okay, so let's calculate. Well, what's the probability of choosing a vowel? We're only choosing one. So how many vowels are there in the alphabet? Well, we saw A, E, I, O, U, so we have 5. So we have 5 total out of 26. Plus, how many letters in the word quiz? There's 4 out of the total of 26 letters in the bag. Now minus the overlap. The overlap, there were 2 total overlapping letters. So we have the I and the U. So 2 out of 26 were counted twice. And then I just simplify that and I calculate. And when I simplify and I calculate, I get 726. Right. Well, let's go up to number 7 and then we'll finish up with number 8. So number 7 here, 2 cards are drawn from a standard deck of 52 cards. Okay, so again, we're using that standard deck of 52 cards that was described above. So we want to find the probability of 2 spades. So I'm going to draw out 2 spades. Okay, the order does not matter. I just need to have 2 spades in the end. So first we want to think about how many total spades are there in the deck. Well, there's 13 of each suit. So we're going to have 13 total and we're choosing 2 of those. That's the number of successes divided by what's the total options? Well, there is a total of 52 cards and we're choosing 2 of those. So we can calculate this on our calculator. If you expand it, you're going to notice a pattern that this ends up being 13 times 12 divided by 52 times 51. All right. And then we calculate that and we end up with 1 out of 17. All right. Then letter 7B, probability of 2 red cards or 2 jacks. So again, we want to think about, are these mutually exclusive because we have the word or. So you're asking yourself the question, are there any red jacks? And by any, in this case, there really are there 2 red jacks because we're choosing 2 cards. Well, the answer is yes. So since the answer is yes, these are not mutually exclusive events, so we have to subtract the overlap. So I'm going to do the probability of 2 red plus the probability of 2 jacks minus the probability of 2 red jacks. So we think about how many red cards are in the deck. Well, half the cards are red, half the cards are black. So we have 26 and we're choosing 2 of those. All right. Plus, how many cards are jacks? There's 4 jacks, so we have 4 and we're choosing 2 of those. Minus, how many red jacks are there? There's 2 red jacks and we're choosing 2 of those. all of these are going to have a denominator of 52 total cards, choosing 2. And when we go ahead and we calculate that, we end up with 55 over 221 for our answer. Number 8, yellow, green, and a purple die are tossed. So yellow, green, and a purple die are tossed. Find the probability that only the yellow die has a 5. Okay, so this one's kind of tricky because it doesn't exactly tell you how to calculate this. You have to interpret what does it mean to be only the yellow die has a 5. So that means that yellow die has a 5 and the other 2 die, the green and the purple, do not have a 5. So we're looking for the probability of the yellow die is equal to a 5 and the green is not equal to a 5 and the purple is also not equal to a 5. So I have that word and in there. That means I'm going to be multiplying. And we're just, these events are independent events. So the value on one die does not affect the value on the other dies. So I'm just going to multiply each probability. So the probability that the yellow one gives me a 5. Well, there is 1 5 out of 6 total sides of the die. Times the probability that the green one is not a 5. Well, there's 5 other numbers besides 5 out of 6 total. And then the last one, probability that the purple die is also not a 5. There's 5 other numbers besides 5 out of 6 total. And I calculate that, and I get 25/216. The last one for today, 8B, find the probability that all 3 die have different numbers. So pause the video maybe and see if you can think about what does this probability mean and how would you calculate it, and see if you get this one right. It's very similar to letter A. So pause the video and then I will give the solution. All right, let's see how you did. So all 3 die have a different number. Well, so what number could the first die be? The first die could be any number that you want. So there's 6 possible numbers that the first die could roll out of 6 possibles that are options, okay? So the first die could be any number. Now, the second die that you roll, let's say it's the green one, whatever number the first one was cannot be on the second one. So there's only 5 options for the second die because it cannot be the same number as the first die. That's why the numerator is going to be 5. All right, probably figure out what the third one's going to be then. Then it's going to be 4 out of 6 because it cannot equal the first or the second die's number. All right, and then we just go ahead and we can reduce and we calculate that and we end up with the final answer here as 5/9. All right, so we're going to stop there for lesson 8.7. We're going to finish up the rest of it with binomial probability tomorrow. Thank you for listening, and if you have questions, make sure you make a note of them so that you can ask in class.